Hi everybody, and thanks for joining for today's webinar. On the agenda, we'll talk briefly about the cybersecurity problem as how we defined it. We'll talk about a new solution concept, what we call security abstraction. And then we'll also get you some technology overview of how we have implemented this abstraction in order to provide new types of adaptive orchestration for your organization. We will go through a demo that show a ransomware campaign and how security abstraction helps to automate detection, investigation, and mitigation of advanced attacks like that, and summarize. So the one principle that we would like to explain is that more is not better in today's cybersecurity market. Empow was founded in order to create solutions that make more of the security tools that you already have. And there is a great need for that, especially after the last few years. What happened in the last few years that we saw more and more advanced attack, higher frequency and volume of what we call, and the market call, advanced persistent attack campaign, which can be typified by the fact that they are multi-stage and multi-vector. They are prolonged, they are more sophisticated. In each one of the stage, there are hundreds and can be also a few thousand of attack vectors, from types of social engineering, spear phishing, different types of malware infection get into the organization, then different types of intelligence gathering, propagation, exploitation, and infection of hosts that take control, and some privileged escalation as well. And of course, end with the bottom goals of data leak, denial of service, or ransomware. Because of these attacks become much more sophisticated and multi-vector, the industry created more and more cybersecurity solutions, hardware, software, and services, which the industry needed to acquire in order to be able to detect, investigate, and mitigate each one of these attack vectors that we see on this diagram. The fact is that all these solutions are required to work in sync. Otherwise, they will not be able to detect accurately and mitigate in time the attack. Each one of the technology can do something very innovative, but it's in a certain scope that is limited, for example, to social engineering, another one for propagation, another one for abnormal behavior, in order that they will be able to detect the attack, which, as we define advanced attack campaigns, they all need to work in some coordination. In reality, the problem is that most of these solutions, if not all of them, although they are effective, each one by itself, are delivered in non-integrated silos. Some will claim, some of the big vendors will claim that they can do it all, but the industry really knows that they can't. And this is the big problem we want to talk about, because these vendors were selling you more and more tools. Today, in a typical medium to large organization and service provider, they have more than 40 different security categories, technologies, and within each one of these categories, there could be hundreds of different product sensors. And it's become really crazy how to monitor all these big data, filter out all the false positive, investigate what is the root cause, and when achieving some level of confidence, start to mitigate the attack. And because of that, attacks are so successful. The advanced attack really go through all these silos. They are not so clear in terms of a single event. Single event will just raise a suspicious activity, but it will not be a definitive attack. And therefore, these type of attacks, this advanced attack, use a lot of events that's only when they are correlated together smartly, an organization can understand that it's really under an attack, or an attack is really going on in the organization. The analysts say the same. If you look on Gartner recent Adaptive Security Architecture report, they are talking about the fact that existing blocking and prevention capabilities are insufficient. And this is based on, of course, wide customer base that they are talking with. They talk about that detective, preventive, and response capabilities from different vendors have been delivered in non-integrated silos. They increase the cost and decreasing effectiveness. So actually, in organizations that invested in the last 5-6 years more than $100 million in solution, in security services, hardware, and software, they become in a state that even if they will invest more, the effectiveness of the solution will go down. And it doesn't matter how much more people you will throw at the problem. This big data problem cannot be solved really with more people. So what Gartner suggests is to have what they call adaptive security architecture. We will talk about it later more when we talk about our technology and how it enabled an organization to have a security adaptive architecture. But it means actually that the technology need to integrate all these different technologies that include detection, investigation, prediction, and response together in order to work in sync. So just to summarize the problem that we solve, as a response to the fact that there was an increase in volume and sophistication of attack, the industry asked more and more tools, many security tools. Each one of them maybe can potentially be very effective, but they are trapped in a silo. They can be hardware, software, and services. And what was actually created is a very complex security infrastructure. Heavy infrastructure, inflexible infrastructure that you can say cannot get out of its own way. And this is why the big problem of time to mitigate, long time to mitigate, arise. So it takes too long to respond, to mitigate, and investigate attacks. Because there is no one, you can say, general that will look on top of all these technologies, services, and all of that, and we say, okay, now there is an event. Let's assign the right tool, the right order. Understanding the event and then correlate another tool. In order to solve that, this is a big problem. So we are coming with the concept of security abstraction. Security abstraction is all meant in order to simplify a very complex operation. And security considered today as a very complex infrastructure. So how we do that? We have developed a software platform, security software platform that integrates with your existing network tools, security tools, network-based security, endpoint security, and services. And we have developed a technology that knows how to break these tools down to what we call individual components or security particles. Each security particle represents a capability, an individual atomic security capability within your tools, your existing tools. And by that, we are creating an abstracted new layer. You can say abstracted new security language that sits on top of your existing tools. And that language, that layer, allow us to turn what you already have into what you really need. So we allow you through this language to create an orchestration, security orchestration model. On top of that, we have developed a security analytics engine based on different artificial intelligence algorithm that we have developed in-house, that when it identifies an event, it understands the intent of the event. And that means we can correlate the best available response. You can say the best available particle in your network in order to respond to that event. By that, we actually reassemble and deploy the new security apparatus for each individual attack that is being developed in your organization, and we do it very fast. We really create an infrastructure that is much more adaptive and nimble. It's not ends only in the detection investigation, into mitigation. So some of the security particles that we are creating are responsible for different types of mitigation capabilities that exist in your network. That can be your firewalls, security web gateways, that can be endpoints, and so on. And we know how to activate that in time as well, once we understand that the attack is going on. So the one thing that you need to understand, which is key in this technology, that we can, by doing all what I just described, we're understanding intention of each event that's going on in your network. Doesn't matter if it's a new intrusion or new malware, and by that, that allows us to make instant correlation. So that's to summarize the process before we move on to the deep dive. We start with abstraction. The abstraction is being built based on our technology, which include a machine learning algorithm that analyze the product that you have through the APIs. And by doing that, it allows us to break these tools down to these particles, create a language. This language is adaptive. As you will see later on, if you have new tools or modified tools, the language will adapt to that. Then we orchestrate through the language a protection model. Who are the particles that you need in order to detect, investigate, and mitigate a type of attack? It could be ransomware, data leak, or others. Our analytics engine in runtime analyzes all the events, understand intention, and by that we can correlate the best response. And when the risk is high, and according to workflow that you can create as part of the we activate mitigation measures. It works equally for different types of attack campaigns. We're talking about advanced attack campaigns like ransomware, financial data leak, privilege escalation, intelligence gathering, and others. We can actually create new and new models based on our language. So just to summarize, in terms of the value proposition that we bring to the problem, to the market, we really identify the fundamental problem and we're trying to solve that. We automate detection and root cause investigation with our system. We provide proactive real-time mitigation of advanced attack campaigns because we are able to do all this detection, risk assessment based on root cause investigation, and then control the mitigation particles inside your network. We offer insight into which tools are performing at the highest level and which are not doing their job. And the reason we can do that is because once we break your tools into particles, we can identify gaps, missing particles that are required maybe to some of the detection, investigation, or mitigation of the attack, and we notify you about it. In general, we're saving on security engineering and security operations center headcount. So with that, I will let Anthony Ferrer, which is our senior solution architect in Empow, to get you to deep dive into the architecture and a demo.
Thank you, Avi. Let me switch it over. So thanks for that, Avi. We'll run through what we have in terms of time, run through as deep as we can possibly go. Any questions, as we said earlier, and any further questions really drilling down into both the algorithms and any part of how we do the abstraction and the orchestration, please feel free to call out to myself, Avi, or Pat. So I'll take you through a high level in terms of the definitions of what we mean by abstraction, what we mean by kind of orchestration and such, and then we'll flip over to the product so you can see you can see an actual demonstration of something that I've compiled from a specific type of attack campaign. So let's start off, instead of talking, let's start off by going through the kind of high-level architecture. So from kind of the bottom up, we mentioned we have a series of different plugins. From an engineering and specifically from an implementation perspective, the plugins would have to be made as simple as possible, and that's only possible in this case through a true abstraction of the capability of the devices. So as I walk through and you have an understanding of what that abstraction means, it means, and to keep in mind, that those plugins become a very simple implementation, a simple way of harvesting information from the existing tools that are in your network, or from the host perspective. So when we talk about abstraction, we're really talking about understanding the capabilities of each of those different devices that exist in there. So when we talk about the security OS, we really have built individual types of engines for each one of those. And then we boil it down further into what we call our expert engines, or the precise capabilities of each one of those that really correlate back to those security abstractions, so security applications. So when we're building or we build those security applications, which by the way becomes one language across the security OS. So from a user construction, that's extremely simplistic. You can chain all of your own events together. You can really drag and drop, and you'll see this in the demonstration, all of the different types of services that you can manipulate. But that means from a high level, whether it's defined by the user or it's defined by Empow, that becomes an extremely simple model to group together those individual security services to form what is an attack and a defense against a certain attack campaign. And then from an analytics perspective, it's feeding those event messages that get triggered in terms of those functionalities up to the risk chain, and those functions that are selected from the security application, and then which get triggered, as I mentioned, you'll see it in the demo, at the risk chain level. That all ends up with a kind of a dynamic feedback, which not only allows us from an orchestration level to constantly feed the model with new types of security tools, but it also from a predictive level, from an analytics level, you can see the same trends and analysis that allows us to be predictive in terms of the future characteristics of a certain attack cycle. If we've seen an attack cycle kind of manifest in a certain way, then we can also be predictive in terms of the spread or the movement of that attack cycle. So that means future defense becomes a lot more simplistic and understandable. And then obviously leading on to the fact that there's multiple ways not only to mitigate inside Empow, but also different levels of mitigation, that choosing the right function to mitigate, likewise choosing the right function to detect, becomes part and parcel of our entire solution, and you'll see that as part of the demonstration. So, as I mentioned, we've created this bunch of plugins that really are there to harvest the existing capabilities of the devices beneath us. So that could be something as simple as a REST API interface, or something a bit more complex like a SSH shell or something like that to gather the information. But in reality, the plugin is a simplistic interface that allows us to gather that information dynamically through the classifier, and then being able to build that higher layer above us from that abstraction layer. So as we take that information, we categorize that information, and we'll go through in more detail how we actually do that classification. And then in a model that stretches across all of the events, so it doesn't matter what type of appliances, in terms of overlapping functionality, in terms of I could have like my SourceFire IPS, and I could have a similar capability in my next generation firewall from Palo Alto, for example. In that case, those functions become normalized and placed into the right container, into the right security particles, as we said, or the right service function that's inside each one of those expert engines, each one of those security services. So by analyzing the capability, understanding its capability, and understanding its intent, when a trigger to that event happens, the abstraction above that, the chain level above that, has a normalized footprint. That normalized footprint can be both manipulated through you as a user using your own kind of service capabilities, and through us applying different types of security application threat defense, like the data leakage as you see, like the ransomware. One thing that's extremely powerful in terms of using that abstraction layer, as we mentioned earlier, not only the abstraction into the different services, but also the different service type engines. Some of those could be harvested beforehand. So like an IPS could harvest beforehand because something like a database exists. But some services happen real time. So as, for example, like a service, like a reputation service, something happens more real time, then we can take that information and we can update that model there and then with that relative information, not just the fact that a user's drilled out to a known website. But from a reputation service, you can look at things like, hit count and other things. You can look at the severity of those kind of actions. And by understanding the intent of what that actual function really means from an attack perspective, we can build the right attack scenarios and inject that information up to the risk chain. So using that lower level machine learning capability within these security service engines allows us to constantly feed that chain which in other solutions in the past has become more of a manual, tedious effect. And any changes below us then becomes a, more of a headache. So in this case, for example, I put a new appliance in there, or we just updated an existing appliance in the network, then now a new series of capabilities, in this case the exfiltration patterns, has been added. So as I say, it doesn't matter if it's an upgrade to the database or if it's a new type of appliances, those functions will get harvested from that device and will be placed inside our model, classified, very specifically classified against its capabilities of detection, classified as well as the intent of what that actual, in this case, exfiltration patterns really mean. And then we'll build that model around that so that when we do feed the risk chain, when we do feed the event engine above us, then we have a true understanding of really what these events mean. So let me give an example of, from the low level, how we actually even classify some of these. So in this case, I've taken two known IPS devices, one Sourcefire on the left and one McAfee on the right, unless you look at it in a mirror. And then, and what we're doing is we're looking at a few different factors, and this goes for each different type of security engines from a classification point of view. Also, and I'll draw in later, some of the other advantages as well of really understanding its capabilities and the capabilities that are needed above it. So in this case, when we do the classification, we're looking at the number of rules. We're looking at the age of the rule. So for example, if the number of rules is like 10, 20, 100, less than 100, if we look at the age, for example, like less than a year to 3 years, or over 3 years old, then we can put a classification around that. We're also looking at the CVE, the Common Vulnerability Assessment. We're looking at the way that this classification, the strength of the classification. We're looking at the manufacturer's detection strength. They're giving a qualification of what they believe the detection strength is going to be. And that's not just on a IPS bunch of signatures, that's also from other types of vendors from their perspective as well. So if we break down that level of information, the numbers, the age of them, the CVE, the actual assessment in terms of the detection capability, then we can start to draw out a cost of each one of these. If we've got multiple vendors with overlapping capabilities, then we can choose the right, in terms of, from a qualifications perspective, the right one for the right job in terms of detection and investigation. So in that level, we can look at that abstraction and we can qualify the capabilities of each of those devices. And as I say, it doesn't matter, in this case I'm representing something that we can pull beforehand. And it doesn't matter if it's a real-time event, as I mentioned, like a reputation service, or something that we can abstract earlier. Also, understanding what features and functionality are there inside the product, it means as we start to classify for the different types, in this case of security applications, we can also see what services are required for each one of these. And if those security particles aren't available, then we can highlight where those security particles are needed. In addition, we can take each one of those security particles from each one of those engines and correlate or group these together as part of that advanced attack campaign protection in case of ransomware and others. And I'll run through this from a demonstration perspective, and you'll see some of those. So switching out vendors, or actually having a different type of service in there from the bottom up in case of Empow, actually doesn't in any way or form break the logic of any of the underlying protection, only the underlying functionality. Because we dynamically classify those, we dynamically understand the intent of what each of those functions means. It means we can feed the service chain, we can feed the risk chain based on their capabilities. And likewise, if we see that those functions are actually missing, then we can also highlight the fact that, for example, if I said my brute force signatures are not capable or not aware, capable means of the detection capability, or even, for example, the function may be disabled on that device. We will, in our model, highlight that that function is needed for that security application that you've chosen, or that security application that you've defined as a user. So piecing together these security OS particles not only gives you the strength in terms of the detection capability and investigation capability, but it also gives you the awareness of what's needed, and also gives you an understanding of what actually is configured and defined on your appliances below. So we group from a high level all of those components together to satisfy those security applications. As event messages come in, the event messages then trigger those functionalities inside each one of those security particles. The weight of those triggers is based obviously on multiple factors. Not only is it based on the intent, as we understand the intent of what that trigger is, what that event is, and that event could be anything across the whole range. But likewise, we understand the detection characteristic of each one of those. So taking into effect the detection characteristic and the detection capability, and taking into account what effect that actual event means in an attack cycle, we can start to piece together very accurately those attack campaigns, which reduces that overall, this event means what? This event means, in this case, in some case could mean nothing, but by having that understanding of awareness and that understanding of detection, you could start to look for things that surround that. If, for example, I understand that a brute force attack is only really, what's the point of a brute force attack unless I know a port is open? In this case, I could look for the port being available using scan. So if I horizontally scan, then I can look, for example, a bunch of hosts, or use a horizontal and vertical scan. I can look for a number of hosts, look inside the host that port is open, and then use a brute force through it. If we didn't understand the intent of the brute force or the horizontal scan, and we don't tie together that level of information, what in terms is the perpetrator, what in terms is the person that's been attacked or the victim. If we don't know in terms of each attack cycle what that really means, then we don't have the capability from an event correlation of really classifying and correlating those together. So you see through the demonstration, you'll see that not only do we understand the intent of the actual messaging itself, but we even understand the intent in terms of the victim versus the perpetrator. And each one of those in terms of an attack cycle. And I could spend all day going through some of those, but I'll give you the idea as well. You think about in terms of what an event means inside an event cycle, and we'll go through those. So as we start to construct the risk chain, we can pick up at any point in that cycle, because as I say, we understand what it means both from the intent, and we understand what it means both from the identification. So there's nothing wrong with us in terms of picking up straight off like command and control or propagation. For example, somebody drills out to a known website. There could be a series of events that have led up to that, but likewise, there's nothing stopping a user from taking a laptop, coming into a premise, and that laptop's already infected. By chaining events together, some platforms are too strict in that nature. You have to have an awareness of what the intent means, and also as an awareness of that cycle. So in terms of my laptop drilling out to a known website, at this case, he was a victim some time ago, but now he's a perpetrator because he's trying to pull out. So in terms of understanding that, the IP flow and the methodology behind it, what you start to look for is that this host is now possibly used as part of a campaign, but is the root or is the source of that. We don't know is the root cause or the root source, but we know the source of that. So further attacks from this to something else will be viewed as such. So understanding those levels, understanding that level of detail means we can accurately draw out that risk chain. And also from the risk chain analytics perspective, realistically understanding and going back and investigating part of these attack cycles is key to Empow's strengths. Understanding, for example, as I mentioned earlier, if there's a port scan and then somebody's trying to do a brute force drill through it, the nature of that attack cycle or even the nature of those actions could lead to an investigation that allows me to find other things that are surrounding that. And as you'll see in the demonstration, I've really pinpointed some of those that not only identify the characteristics of the attack, but also the historic investigation that allows us to further guarantee that those are not false positives, they're actually part of that real attack campaign. So I'm not going to go to this in much detail, but here's a higher level view in terms of the risk chain discovery. This is what you're going to see in terms of the actual demonstration. So I don't want to dwell too much time on it. But from a an actual point of view, we're looking at it from the analytics and orchestration model is actually looking at it from the event perspective. You can look at it from the host as well, but realistically, we're looking at it from events. So you can gel together, it gels together or constructs from a risk chain analytics the events that are relevant as well as the metadata behind the host as well. So we'll go into it. From a demonstration perspective, I've built a demonstration around a ransomware campaign. And as you draw out a ransomware campaign, you think about the things in terms of understanding where the data is, being able to privilege escalation, get it to a point where I can actually either download something like malicious code, where I can find not only finding the server, but find the data I want to encrypt, so on and so forth. So you think of the actions of piecing all that together before actually ransomware gets downloaded, before any encryption actually is performed. There's a whole bunch of steps from a security aspect that we can start to form together to prove investigate, and mitigate that there is an actual campaign of such going on. So with that, let me flick over to my software that's running on my laptop. And this is a live version of the code. What we have, a little heads up beforehand, we actually have a way of being able to replay event messages back into the system, and then the system's going to crunch through those and come up with what it sees as an attack campaign based on whatever's configured. So let me log in and then talk you through it so you can see it. So just moving you out of the way. So I'll go from like a configuration, so it puts it more into context of what you can see. I've created an advanced attack campaign that I call ransomware, but you can actually click on the Go to Store button from an Empow perspective, and it will download by choosing like privilege escalation, ransomware. You can download this instruction set of security particles that are needed to protect against, in this case, privilege escalation and ransom, whatever. So in terms of I'll just click on intelligence gathering, and as you can see, that's got downloaded, a little E to show that it's an Empow defined one. And then if I look at the playground that's surrounding that, these are the services, the security particles that are constructed for that attack campaign, to protect against that attack campaign. Interestingly enough, if you look under the investigation, the reputation service, it says there's no service manager device available. What's actually interesting, as I mentioned earlier, when we look and we classify those security particles, we can identify those functionality, or in this case, devices that's missing, so that you know from a protection, whether the protection is from an application that's downloaded by Empow, something that you've constructed, that it's deficient in some way or form. So if I go back to mine, I want to show you more in-depth one, because of course I've been playing around with it. So as I go to my ransomware campaign, and I've put together a whole bunch of kind of detection and investigation engines, I'll drill down into one, I'll drill down into my IPS, just so that you can see, as I deconstructed in the slides, as we pull that capability into the model, as I mentioned, the age of the signatures, the number of signatures, the CV information, the actual accuracy level, the severity, so on and so forth. We can actually classify those not only under the right expert engine profile, like under here, so that becomes a normal series of events, irrespective of the manufacturer. And I hear everybody screaming out, well, what difference does that make? But as you feed that level of information to an analytics engine, there's no break in communication below, because what the analytics engine is seeing is a normalized set of data. In terms of a triggered event, yes, it's triggered in this case for McAfee, or it's triggered in case of SourceFire. But the information that's led upwards is normalized. So any addition, any changes, any appliance alterations, whether it's an upgrade, whether it's a new appliance, does not break step in terms of the detection. If it's got more functionality, it becomes more information fed to the risk chain. It's not less, it's not restarting, or it's not having to recompile from the beginning. It just feeds that more data into there. So as I look for, let's use network security patterns in this case. And in this case, it's classified SourceFire as a higher priority based on the old database. It's actually June, so it's a European day. The old database that I've implemented. And based on the, as I say, the types, the numbers of signatures, so on and so forth, it's classified that with an accuracy and a weight level that will get fed into the risk chain as those events get triggered. So as I switch over now to an actually attack that I've attack campaign that I've actually I've constructed, I'm going to start from the timeline of 0, which is quite interesting because from an Empow perspective, you can wind back the clock to the beginning of the attack cycle. In this chance, as I march ahead without telling you, this is a state of closed in terms of the attack campaign's being closed. We've mitigated against it in terms of the M is mitigated. We've also used the tools of detection and investigation to get to mitigation. And I'd say each attack cycle, depending on its level of both configuration and a level of of detection capability and a level of where you want to drop, where you want to start to add mitigation, is all configurable inside the model. So as I start to draw and I start to look at this attack campaign, the first thing that we picked up on as a segment cycle was actually a propagation. And in the case of an attack campaign, as I mentioned earlier, it could be any part of the cycle you could pick up on a chain event. And then you could start to chain together the series of events based on an awareness and an understanding that these are actually correlated. So as we draw out the attack campaign, these guys here, I know from he's gone out to a bad known website. It's a command and control. So it's a known website through a threat group, through a reputation service. And we picked up on one event. We could actually go down and look at those events, but before I do that, before I piece that together, we can look, for example, what's kicked off an investigation, what actions have been chained together to be able to say, wait a minute, let me actually look further into what's going on. In the case of this segment, if I look at these, I can see two different types of actually from the situation of the 2699 from one host to 2696 and vice versa. So there's been a bunch of messages that have been correlated together, in this case, two different types of events. So it could say, from a detection perspective, there's a privilege escalation patterns and anti-scan. So we've had 3 events that have triggered off. And likewise, in the other way, an abnormal scan, an anti-scan, so like a horizontal scan, and then an abnormal data transfer. So somebody's like scanned the host and then he's transferring data from that, opening that port. When we've gone back and investigated, because those 2 events alone have kicked off a, wait a minute, what's going on, as a user would in your mind, we've actually found, looking at these engines that I've got in my investigation phase that I mentioned earlier in my playground, those engines specifically have been investigated to say, is there anything around this host, the behavior of this host? And we found an event. So they've gone back historically, of the engines I've chosen, the engines that were selected in the playground, which are those security particles. And those engines, or security particle engines, have detected historically an event that can be correlated to the existing event today. So we've identified, through these type of actions, through both the flow of the data, understanding the flow, understanding the intent of those, and then looking for specific events that correlate back to those, we've investigated further. That allows us to be then more confident or have a higher confidence level when we go to actually mitigate or control it. So not only do we choose the right engines from an investigation when we followed on from a detection phase, but from also by understanding the intent or the type of attack intent, we can also mitigate using the right type of actions. So in other words, if an action is a DDoS attack, there's no point just putting an internal DDoS between 2 hosts. What's the point of putting like a rule down at the firewall gateway? It's got no intent. It's got to be internal. I've got to know that I'm connected to the top of the rack, maybe, there's that host. Likewise, if, for example, the host is drilling out to a website, or even if it's a server, like it's an FTP server or a DNS server, and he's using DNS to drill out, I don't want to block DNS. So in that case, my action to mitigation is going to be a high-level layer 7 information. Maybe I need to write a regex to like an application firewall, or something like a Palo Alto that's got more capabilities. In that case, I'm choosing the right job, or at least the right function for the right job. Whether it's detection, whether it's further investigation or really whether it's mitigation. So let me, before I go and show you the proof in terms of those event messages, let me draw out the cycle, or as Abby likes to call it, the octopus, which it does look like an octopus. So a couple of key factors here on the left is that not only, all right, I've got plenty of mitigation, but the mitigation is very specific in terms of the intent. Is this being spread? Is this like a command and control in terms of the actions that are being spread? In the case in this left here, in these cases here, it's just a network scan pattern. You're just probing. I don't need to mitigate that from a probe perspective, but I need to prevent this host from doing anything further. So mitigate the actions that lead to something. Don't mitigate the actions that really are irrelevant in this case. So understanding intent, understanding the function behind the intent, and then act accordingly. So let me go back to my my pair. And likewise, these down here, we can actually look, we can filter on specific events in terms of understanding the host, you know, blocked host and detection host behind it, host groups behind it, and really drill down into those intents. And likewise, I mean, a lot of people ask in terms of, say, for example, in my network, it was a pen testing device. Yep, you can add that to a whitelist and so on and so forth. So we have an understanding of network topology as well within my network. What does that mean? What do they mean in terms of functions? Can I have an awareness of both the topology information, the event information, and what else is going on that really shouldn't be blocked in terms of a pen tester? Yeah, and you can add all those kind of metadata levels to the engine so that it has an awareness. So let me go into this guy and literally go down in terms of, I want to see from a actually interesting thing before I go to the event messages. Even though it's running on my laptop, we actually look at that, the bytes, both for the bytes and the drop packets. So when we apply a mitigation rule, we're monitoring the status of that rule for two reasons. One is the attack cycle still going on. Is it something that's actually disappeared? Then I can remove that event, that mitigation rule for. So we're not just set it and forget it, as a customer of ours said yesterday. Even though what he was looking for was a set it and forget it platform, which is pretty much what he looked for, was the ability to say, you tell me what's going on and then you mitigate if necessary. But in terms of mitigation, we monitor the status, as you can see, 0 bytes in this case because my laptop is connected to nothing but the Wi-Fi. So then let me drill down to these event messages here and then show you where we picked up on those. So in terms of the event messages themselves, the actual abnormal data transfer and horizontal scan was picked up from a user behavior analysis tool. In this case, it was our own, but it could be, you know, any user behavior analysis or network behavior analysis that's in the network. And then from an investigation, we've gone, let me go and probe an engine that relates to this behavior in this attack cycle. In this case, I'm going to go look for some malware, and it's gone back to the last line, which was a product that was connected to my live environment, and lo and behold, it found a ransomware. So in terms of, I can actually look at the vendor's information as well. So let's let me look at the vendor in ours. So this was from a scan perspective. Normally this host is doing 7 connections within that timeline, and now he's doing 23. So I know there's something going on in terms of that level. But likewise, in terms of my last line perspective, I can look at the terms of the binary and the category and look for the confidence level that we've classified. I know that from a confidence level, both from an attack cycle and the behavior of the other events that have led up to this, we've got a definite segment that's related, both from the IP source test, the use of the ports, and the actual event messages that we used inside there. So as we draw back to our attack campaign, the hosts that were involved, or the event metadata that was involved in this attack campaign, can get all tied together to prove that these not are isolated segments or isolated events, that they are part of that overall attack campaign. And as the timeline draws out, I know I showed the timeline in here, sometimes what you'll find with an Empow perspective, you'll actually see segments that are initially start off as being completely unrelated. As it starts to investigate, find further information, they can start to be folded together. So as we look back to the attack campaigns, in this case I've got 1, you'll see 2 or 3, and they get folded together as it becomes obvious. As say from a detection investigation, they become obvious and get folded in as part of that attack cycle to show that this is actually part of a living and breathing a bigger attack cycle. So that gives you brief taster into Empow, and there's a lot more obviously we can go into. It gives you an idea in terms of its functional capabilities. Here's a list. It's just a brief list of some of our bigger vendors in terms of what we've from a product support, from a plugin perspective that you can see. We're adding to that list. From a kind of reiterate or strengthen the argument, when you look at the actual security services above it, the WAFs, the IDSs, the anti-malware, that's where the pain factor is. That's where the engineering effort goes into. The plugin that leads to each one of these is very simplistic. It's just a way of harvesting its capabilities, and we're abstracting that into our model. Whether that is in a real-time event message model that gets classified in real time through the machine learning, or whether that's a preemptive beforehand like an IPS, where it can be abstracted and classified beforehand. In both environments, the pain point is obviously with the supported products, is with the security services. So adding to this is very simplistic. And we've just for time check, or at least a check, to give you an example, 2 customers yesterday had a different product, one in terms of wanting to add that, and it took us a week to add their functionality back into there. So things like, adding firepower from Cisco Firepower took a week or 2. So in that case, those kind of functionalities get added very simplistically because their capabilities break down across the different security services models. So as we mentioned, and as I showed in the demonstration, the cross-correlation and cross-awareness of both the intent, understanding the intent, understanding the capabilities and strength of each of those devices, allows us to simplistically take all those event messages that are seen by everyday IPSs, everyday mitigation services, whether it's anti-malware, whether it's reputation or whatever, and realistically adding context around it, adding a reliable service that allows you to reduce that overhead of false positives. And likewise, understanding the intent, understanding the capabilities when they are used in a true attack campaign allows you, from a signaling perspective, to actively mitigate, protecting beforehand. Any of those cycles can really get a hold inside the footprint of your network. So realistically understanding it, dynamically understanding both the capabilities of the devices as they get updated weekly, monthly, without any user interaction on Empower side, and then being able to dynamically mitigate and identify those advanced attack campaigns before they get a hold inside your network. So really going back over what kind of Abby mentioned earlier, from a real-time mitigation perspective, we can only do that because we understand the intent and the capabilities. From an insight into the tools, really analyzing the capabilities of the tools, both down to that particle level, being able to classify them on ingest into our model, both the capabilities of the different types and the detection strength of the different types. Not just being able to understand what they can do or what they're configured to do, but also the detection strengths, so that where we have overlapping functions, the choice of the right tool to detect in the right area is paramount. And then obviously saving on all of the operational, from a detection perspective, from a SOC environment, really reducing down those false positives. And obviously automation root cause, so it kind of talks for itself. So very quickly, a little bit about Empow. That engine that you briefly saw, in terms of 2 years of development work beforehand, we've got existing customers. So we went GA version live at the beginning of this year, where we went live with that, with a large environment, 10,000, largish environment, at least 10,000 users plus, and millions of flows in terms of event message data. And realistically, we've gone on from there. In terms of security expertise inside the company, a wealth from firewall to anti-DDoS, which is quite close to our hearts, to network behavior analysis engines and so on and so forth. So we do have mathematicians in house, obviously, but we're not just an analytics engine. We understand what these detection, we understand what these attacks really mean. Else we wouldn't be able to build this kind of modules. So, and it says there, turning what you have into what you need. So I'll pause there